Okay, last video for conic sections is on parametric equations. Parametric equations. There we go. The parametric equation is an equation that's not totally defined by x's and y's. Parametric equations also have an additional variable, which is usually t, which is another variable, and t usually indicates time, or in other words, this graph of x and y is changing in time. Something is happening. It's an additional variable which is changing things. So it's another dimension. It's usually time, so it usually means movement. So it might indicate a particle is moving somewhere, it's doing something. If it's a circle, the particle might start here and move around the circle, If it's in a sine wave or something like that, the particle starts somewhere and moves somewhere. So it's usually indicating movement, sort of thing. But we'll have a look at that. The cornerstone of trying to, if you're asked to convert a parametric equation into a Cartesian equation is just defined by x and y. Okay, so just x and y. If it's got another variable in there, that's when it's parametric. Like I said, the most important thing is to know your Pythagorean identities. This is your first Pythagorean identity, and I'm not going to prove it, but it's because of your unit circle, which has a radius 1, and that there is your cos. If that's the angle x there, that'll be cos x, that'll be sin x. And so using Pythagoras, you get the identity, the Pythagorean identity, that sin x squared plus cos x squared is equal to 1. It does not matter what the angle of x is, this will always hold. So that could be 2x, it could be 30 degrees, it could be t. It does not matter what this angle is, this will always hold. And this is what you can use to convert a lot of parametric equations into Cartesian. While we're here, let's look at the other two. If you divide everything in this equation by sin squared x, then what do you get? Well, sin squared divided by sin squared is 1. Cos squared x divided by sin squared x is actually tan upside down. The inverse of tan, the upside down of tan is cot squared x, okay, because it's squared. And 1 divided by sin squared x, what is upside down? Sine is cosec, cosec squared x. So there's another identity, okay, just dividing by. Similarly, if we divide everything, going back to our Pythagorean identity, if we divide everything by cos squared x, what do we get? Sin squared divided by cos squared, well, that's tan. So tan squared x. Cos squared divided by cos squared is 1. And 1 over cos squared is sec squared x. And so there are our 3 Pythagorean identities. 1, 2, and 3. They are on your formula sheet for your exam, but it's often helpful to know where they come from in case you get stuck and you need to be able to figure out what they are. I tend to just figure these out in my head as I'm going. I can't really remember them, to be honest. I just use this sort of process in my head when I'm trying to figure them out. Okay, so let's just look at some typical sort of problems. Okay, so if you're asked to convert a parametric into Cartesian, so if you're asked to x equals 3 cos 2t, if x is equal to that, and y is equal to 3 sine 2t. Convert that into Cartesian. Now, what we've got here is x in terms of t and y in terms of t. In other words, the x value, the left and right, is moving to something according to t. In fact, it's cosine, so it's moving backwards and forwards in terms of x. The y term, up and down, is moving in terms of sine. So that again is moving up and down, It's periodic in its motion. And so in terms of time. So let's have a look at this. What we can do is, if we can get cos 2t by itself, then what we do, x over 3 is equal to cos 2t. Got that? And also y on 3 is equal to sine 2t. Fantastic. So I've got these things. Now we know that cos squared 2t plus sine squared 2t is equal to 1. That was our Pythagorean identity. Remember, cos squared anything, it does not matter in here. As long as these two angles are the same, it does not matter what angle is in there, it'll be equal to 1. So if we use this, we can write this out. So let's have a look at that. What is cos 2t equal to? Well, it's x over 3. So what we can do is, it's whatever cos 2t squared is, so it will be x over 3 squared. That's cos squared 2t, because cos 2t is x over 3, and this is just squared. Plus, that's the worst plus in the world, sine squared 2t. What's sine 2t? Well, sine 2t is y over 3. So it will just be whatever that is squared. So y over 3 squared equals 1. What have we got there? Well, it's very close to looking like what a, well, what is that? You tell me. 3 squared, so 9 plus y squared over 9 equals 1. And then you might go, well, that's obviously an ellipse because it's equal to 1, and you've got this certain form here. But in actual fact, if you get the same a and the same b, if they're the same number, this is not an ellipse, it's actually a circle. So if you multiply both sides by 9, you'll get x squared plus y squared equals 9. What is it? It's a circle centered at 0 with radius 3. And that's how you convert these things into Cartesian equation. So this is the Cartesian equation. What it means is that there's some movement. If you look at what t is equal to 0, where is this particle when time is equal to 0? Well, if t is equal to 0 here, what's cos of 0? Well, cos of 0 is 1, and so x at time 0, x is equal to 3. So that's that point there. What is y equal to when t is equal to 0? Well, sine 2t will be sine of 0, which is 0, y is 0. So that there is the very first point. That's t equals 0, right there, that little point. If you then go on to it, well, what's when time's equal to 1, or something like that? Let's just do it. Time's equal to 1. What will the x value be when time's equal to 1? Well, that'll be cos of 2. That's a little bit messy. Let's just do times equal to half. That'll be a little bit nicer. So at time equal to half, cos times 1, well, cos of 1 is 0, 0 times 3. So the x value when time's equal to half will be 0. So it will either be there or there. How about the y value? Y equals 3 sine of 1. What's the sine of 1? Sine of 1 is 1. 3 times 1 is 3. So actually, when time's equal to a half, the point is now up to there. So let's have a look at this. At time 0 it's here, at time's equal to a half it's there. This point is actually moving around the circle like this, around and around and around and around. And so we've actually defined movement around a circle, which is a lot more interesting than just plotting a circle like that. It's boring. If we introduce a third variable t, then we can actually show movement around these shapes. And so what we currently know is we know circles, ellipses and hyperbole. So you might get parametric equations which go around an ellipse, around and around and around. You might get parametric equations that go around hyperbola. They will go down there, then over there, then over here, then over there, and they'll continue to do that as t gets bigger. So that's parametric equation, that's how they work. We'll go into those more towards the end of the year, but the important thing is to recognize your Pythagorean identities. If you've got coses, use this one. If you've got secs and tans and that sort of thing, use one of your other Pythagorean identities.